Cool. I was saying that, I haven't really slept that well recent nights, and it's because of a thing that's happening in the world that I think is capturing the attention of all countries and everyone. And I'm a bit tired today, and I guess all of you have watched the election, or what do you say, Lars?
Yeah, I was up really late on the election night as well. Yeah, it affects us so much, everyone. So it's interesting to see.
I guess you as well, Henrik, or?
Both yes and no. So I had so much going on, and we were sort of putting it on and then off, and then we got up really early and watched it in the morning. So I would say we kind of watched it till like 12 or 1, but not the whole night sort of thing. No.
I try to stay away as much as I can, but it's really hard given the media attention that we have right now.
Yeah, but it's interesting now. Of course, being interested in data and analytics. How have you? Do you think they've been doing a good visualization? Is it easy to follow? Is it good? Could they do it better?
I stumbled on the New York Times page, and they were doing some really impressive visualization, helping you to understand and so forth. But they stand out. And
what did they do?
You could interactively go and explore the swing states and the different counties and so forth with detailed statistics on how each county was doing in the voting and in the counting and in comparison with the previous elections and so forth. And I think they stand out, and you can clearly see that they have become like a data mature company and have got a grip on how to work
present
with data,
the data,
so forth. If you look at technical conferences, they are frequently there presenting what they're doing, how they're working.
It's really great to see actually a media company that actually knows how to work with data properly, which is rather scarce.
But you commented before, Anders, why don't we see trends?
I'm a data nerd, so I just get annoyed by, why don't they have this obvious kind of visualization they should have, to really, tell what's happening.
The trend.
But I'm damaged from work, I think, for doing that. But one other thing that I really get annoyed with is how poorly the opinion polls are, measuring up.
They are just like the previous election.
Exactly.
But we have to remember that this is a very difficult thing to predict and project because you don't have any reliable measurements anymore. I mean, in the past, when we were responding to these CFO things, they would call everyone, and then you get an unbiased view of the society. Now we don't have fixed phones; we can't reach everyone, so every measurement we do is naturally biased. And then the rules are different in different countries, and people are online in different patterns, and so forth. And it not only differs between countries, but also between the states in the U.S. So the sort of the underlying election algorithms are different. So it's a really difficult challenge to do properly.
It is.
So, before we leave it, I actually did a Google search today in the morning now, when it's still not decided, blah, blah, blah. And I typed in AI plus US election. And one of the top hits I get, or one of the topics you get around this is several articles around a quite elaborate Twitter analytics initiative that has been done previous to the election, where basically using tweets as a way and scraping that as a way to understand sentiment, and from sentiment understanding where will this go. And the interesting point is this model actually predicted a very close race. But they were doing it nicely. That they weren't saying that they had the perfect model. They were very humble, but they were much closer to the reality where the polls were talking about the landslide for Biden.
Maybe that's because they measure how the Russian bots will vote. Yeah, that's actually.
But it's interesting, because in the article it also highlights the tricky point of doing a model on tweets, because of course the whole model is from the beginning biased. Ultimately, who is on Twitter? And it's a clear difference, but they kind of took that into account, and they compared it and pumped the model up with data from last year. Interesting, I think.
Speaking about using Twitter for trying to understand some kind of sentiment in the society. It's moved to Corona as well. And we actually in Peltaren also did a Twitter sentiment analysis or toxicity analysis of Corona and actually fed that to Riksbanken and have some kind of live understanding of what's happening. And this is actually, I think, an expert topic for you as well, Lars, that I know did some investigation into trying to understand, how to use data quality or data for Corona. What was that about? Can you?
Well, I wanted to do something, right? Yeah. Everybody wanted it back in February. Exactly.
How can I help?
And I've taken on as a life mission to go out and help companies, organizations get the superpowers of data, and that has turned out to be really difficult for companies to get mature in that sense. And usually I just shrug my shoulder and go to the next company. But in terms of Swedish health authorities, there is no startup that we can hope to come and disrupt them, right? They're just the one and only. And we actually did a little effort trying to help with projections and so forth. There was us and then a small data science startup called Model AI. So we had a model with where you could predict how Corona spread based on anonymous mobile data and so forth, and try to get the chain and data from the mobile actors out to the regions to plan for the outbreaks and so forth. And we got a lot interest from several regions, but we weren't able to pull the whole chain together, unfortunately. So I thought, what else can we do? So my contribution in the end became this presentation where I use COVID-19 and the response and highlight how much value from data that we're leaving on the table by not handling it properly, and how much more we could do. After that presentation, there was this incident in the UK where they were missing, tens of thousands of tests because they mishandled some data in Excel.
But I think, could you give us a snapshot? Because you actually did a very applauded presentation at Data Innovation Summit this year. And it was quite interesting how you, with quite simple techniques, could basically dissect the data set and how they have used it, and if there was any real, what was the data robustness, so to speak. So please, could you, that was very interesting. So for the ones who didn't hear that one, could you give us the...
So a sort of a couple of highlights. I tried to show how some common mistakes that you make when handling data and mishandle the data quality, and how that leads to wrong conclusions. So one of the focuses of the presentation was if you mishandle code quality and omit the software engineering piece, you end up doing what the Imperial College in London did, where they actually published a source code, which was great until I looked at it and I became terrified, right? That source code that would never pass an undergraduate course in university. And I looked at the code and I said, there is no chance that this code could produce the right results. Yet the outcome of that code has affected lots of government policies.
And give some technical details. We have some
now let's
people.
go nerdy on this one. Let's
what
really
kind
go
of code
nerdy.
was it? What language was it? What they trying to do actually?
This is super interesting.
In theory, it was C++. I mean, syntax-wise, it was C++, but it doesn't look like C++. There were functions that were 800 lines long, and they didn't know fit on a screen. And you could
lots of tests, of course, full test coverage.
Well, there was actually one or two tests, and
really?
Yes, that was surprising. But they tested that they were pure regression tests. So they tested that the code produced the same incorrect result as the last time. but they actually didn't work. So they had to disable them because the code was completely indeterministic. So if you changed the number of threads, for example, the outcome result differed by 20%.
So just the number of threads changed the actual data.
If you just change purely technical parameters, and I didn't do these tests, but there's a great code review out there by an ex-Google engineer linking to some experiments that have been done on the code, the response when they were criticized here was staggering as well, because there were like GitHub issues, and someone said that there's this constant number of days in a year, and it's 364. Surely that's not correct, right? This was actually leap year, so this should be 366. And the response was, no. In C++ you count from 0, so that's right. And then I looked at the code, and it was, no, that does not correct, right?
Yeah.
And it had all these blatant problems all over the place. And there were Swedish researchers that ran this code on Sweden, because Sweden didn't do the lockdown that the Imperial College were advocating for and so forth. And after the fact, the outcomes in comparison to the model were off by a factor of 20. Right. So that's
outcome
how
in terms of the spread, or what's the outcome in this case?
The number of deceased in Sweden. So they exactly. So they had predicted about 100,000 fatalities in Sweden by now, given the measures that were taken in Sweden.
It was off by a factor of 20 or something.
A factor of 20, yes. And they concluded in Britain that. Well, it's great, the authorities listened to us, and then so we saved hundreds of thousands of lives. So they were celebrating their own incompetence.
But it's so many disturbing points here. But let's break it down. I mean, so one of the key things here is a little bit like, let's talk about a profession now. Who do you think made that code? What profile of it? It's clearly not a data engineer, but rather a data scientist.
So, I mean...
No, that was a cheap shot.
I'll pass on that one.
We have, by the way, one data scientist and one data engineer. I couldn't help it.
We're sitting on different sides of the table. We can throw crisps at each other. Yeah. No, they were domain experts, right?
Domain experts.
Right, they are epidemiologists, and clearly they had no software engineering expertise in the room. And it's fine. People don't have to be software engineers, but then you take some help, right? Yeah. It's obvious. It's like driving a fleet of ambulances and never taking them to the car mechanic, right? It's obvious that things will go bad, and they did.
You can do some things as a domain expert, but other things you need help with. Yeah, and if it's a car, you can drive it, but perhaps you can't fix.
But this is one of the most concrete, very big blow-ups that highlights the need for cross-disciplinary ways of working when you do data ops and data science and all this. Don't try this as home folk on your own. That's my bottom line. I just want to nail that down. That here and here we have the other disturbing fact. Then what happens now? We become data-driven and we start acting upon it, and it's wrong. That's quite disturbing as well.
And that's kind of an example of the opposite arrogance, right?
Yes.
That when data engineers and data scientists sit on one side and say, we have mastered deep learning, we can tackle any domain, and how hard can it be? Right. Yeah. And we have thousands of failed startups on like that assumption. So I'm utterly convinced that we work best when we combine the technical capabilities with the domain experts and try to be humble and learn from each other and work together.
And then going all the way back to this AI After Work podcast, we need to have the different perspectives working together. And here we need to get the same lingo. We need to understand each other. And we need to start understanding that this is a cross-disciplinary approach.
Yeah, and I think it's a classical thing we have spoken of a number of times, like the catch-22 of you have people knowing the domain and are experts in that, and they don't know the computer science and data science behind it, but they know the domain. And then you have data scientists or data engineers that know data and computer science really well, but don't know the domain. And if they don't collaborate, it will not work well. And you wish you could have both, or better tooling or something to enable, if you can enable domain experts that really, use data and AI properly, then we would have a really nice situation. But we're not really there yet, or?
No, that's a long journey. I think the simple answer is just like working together. And going back to COVID and that presentation, one of the other topics was I looked at what the Swedish authorities are presenting, right? And they don't have this. I know that not everybody likes them, and I'm not saying whether they're doing the right and wrong things here, but they don't have the same arrogance with respect to people pointing out their mistakes. But I follow these presentations that they used to hold them every day, now twice a week, and every day you see them show these curves, and they say, oh, here's the last week. And by the way, the last bar is only 3 days, so you can't compare that bar with the other bars. That's not rocket science, right? In analytics, every time they have to explain the fallacies or the imperfectness of their own displays. And earlier they used to show the number of deceased or the number of intensive care, and it was always dropping at the end. It's like, why is that graph always dropping? Well, it's because of slow data collection. It takes a couple of weeks for the reports of deceased people to come in, and that's fair, right? But then you shouldn't show a graph of all the data that you have where each bar is not comparable to the other bar.
Please take out the non-comparable bars.
Exactly.
Maybe.
Or, I mean, there are lots of things you can do. And in the presentation, I go through a bunch of things. I go through how to make the data, how to compare comparable data, or how to make projections. And this is a good highlight of the data mature companies versus the non-data mature companies, because the non-data mature companies, they are still doing these things with like craftsman's tools, like hammers and manual screwdrivers, right? And they might be really good at this. But in a world where the leading companies have industrial processes in place, right? They are outcompeted. Now, if it wasn't authorities, they would go out of business. But now they are authorities, so they're the only ones that we have.
So we let's explore this further down the track. But we now have almost like a custom workshop, like I'm building cars in a custom garage.
Exactly.
Versus this is Stuttgart, right? And we have the BMW's full production line.
And that is a good analogy, because the companies that are best at doing what we call data ops and after that machine learning ops and so forth, that is very influenced by the lean principles of Toyota, right? Cutting waste, discovering problems early, minimizing the lead time, and so forth. And I remember when reading this Toyota Way book. That is the book that has mostly affected my career so far.
So I think this is an awesome topic of discussion. But
let's
before
do the segue. What started his career? Let's jump on the segue.
Exactly.
And then start now. What career?
What career?
What career?
Yeah. Who is Lars Albertsson?
Who is Lars Albertsson?
Yes. So my first career steps was during university. I worked a bit at IBM with OS2 systems. Not a lot of people have worked with those.
I did, actually.
At the time, I thought that, IBM had this cool level of automation, but I have afterwards realized that's where I first encountered the going from craft to factory. Because back then I had a Windows 3.11 machine at home, like a Pentium 120. And it was really a pet, right? You massaged it, and if it had a virus, that would be terrible, and you had to work so much just to keep it alive, right? And you could see that out in the professional world. You had to spend lots of time just keeping the Windows machines alive.
That was your pet by then. I like that comparison.
And when we
Tamagotchi.
When I worked at IBM. We didn't treat these OS2 machines as pets, because whenever something was wrong with them, we just went with floppy, we booted them, and they would contact this installation server, and they would be rebuilt from scratch from the definitions in the floppy, and they would probe the hardware and install the right drivers and reboot 11 times and so forth. Some people got confused and said, who deleted my local files that I put on this machine, because that's what we used to. But essentially, with that OS2 installation, you had gone from a craftsman working with craftsman's tools and shaping your car in your garage to a factory where you build things from scratch. Now this is the same way that we build containers today, and this is the same way that we build data sets in a modern data environment. But
so this was your first encounter with factory thinking.
Exactly, with factory thinking. It was we could administrate like many dozens of those machines with very, very little effort. So from there, at the end of my studies, I did my master's thesis in the Center for Parallel Computing in Stockholm. So it was a traditional sort of high-performance computing environment, working with data visualization and parallel computation. I moved on to SIX, Swedish Institute of Computer Science, stayed there for like 10 years, doing research in mostly in distributed systems and to some degree in networking. I ran one of the first IP version 6 nodes in Sweden, or the first IP version 6 node in Sweden back then.
Cool.
And that...
when is this?
I started there 97. I shut down the node in 2006. This was the 6-bone experimental network, and it was killed on June 6th, 2006.
To remember it.
Exactly. And then I felt that
the 6th of the 6th, yeah.
Maybe I was done with academia. I got to the stage of almost having a dissertation, but I realized, in a sense, what I had done could not be used because it was tied to proprietary hardware or proprietary software, and it wasn't as valuable as I thought. So I ran out of steam before I did my PhD. And when I thought it was time to change tracks, a Google recruiter called.
So before that, but you started some PhD work, right?
Yes.
And what was the topic of that?
So the topic was to use virtualization, this was before like VMware and so forth. But you use that type of instruction level virtualization for the purpose of debugging and testing and analyzing distributed and multi-threaded systems. So I built on top of a simulator, which was the name for the virtualization at the time. I built like debuggers so you could go probe into the virtual machines and look at their state in the same way as you would debug normal programs.
So you can say you started working with a precursor to Dockers before, and you started to work with a precursor to the virtual machines we all use today in cloud computing?
In a sense, the purpose of these machines were not to run things in production, but to study. They were at first used for evaluating hardware, like simulating cache hierarchies and so forth. I did a sabbatical at Sun Microsystems building hardware. And we use these simulators to validate that the systems worked as expected, and sort of to run
like a simulation environment in some way.
Yeah, exactly. And there were a couple of these. Nowadays, the only popular open source one is called QEMU, but that wasn't really around at the time. This was a Swedish thing called Semix. They eventually got bought by Intel. There was a competing one from Stanford called SimOS, and that one never got commercialized, I think, but the research group that did that eventually moved on to do research called Disco, and that became VMware.
Oh, really?
And at the time, we were also collaborating with a group in Cambridge around, and they moved on to do Zen, which is one of the popular virtualizations today. I think it drives AWS, if I'm not correct.
Oh, really?
Mistaken, yeah.
But Google Recruiter, that sounds interesting. So what happened then?
Yes, and this was 2007. It's now a long time ago, and that was at sort of the height of the Google hype. So that was interesting, and they were looking for SREs at the time, and that was
SREs.
Yeah, software reliability engineers. The SRE concept is, you could call it Google's implementation of the DevOps philosophy. But both DevOps and SREs were completely unknown concepts at the time. And you have to have a certain, in order to work as an SRE, you have to tick off many boxes in your resume, like coding and testing and operating systems and networking and yada yada. And I happened to tick all of them, so I showed up in their recruitment scans.
So then when they did the sort or the search, you had one of the resumes that fitted that.
Exactly, they fitted all of the checkboxes, right? So I, Google called me and I could fly to Zurich and have some interviews with them. That's great, nothing to lose, right? So I went there and I flunked the interview for the SRE. That turned out to be more sysadmin than I thought. Then they called back and they said, well, it seems that you fit better for this role called software engineering test, which is like test interested software engineering, basically. I didn't flunk that interview, and I got a job offer down in Zurich. I looked at the numbers. This was before the climate disaster. So I considered flying there every weekend, but the numbers didn't add up. It would be too expensive, I realized. So I declined. And then they called me 3 days later and said, "Hey, we now bought this company in Sweden. Like, do you want to work in Sweden?" Okay, where are they based? They're based in Luleå. I'm not going to Luleå. Sorry. I mean, Luleå is a nice place, but I've lived my whole life in Stockholm. I'm staying here. No. They have a couple of people in Stockholm. Okay, what are they doing? They're doing video conferencing. The company is called Maratech. And I said, okay, yes, whatever. I had done some networking, so I had useful skills, but I don't know anything about video conferencing, and I don't know if I think it's fun, but never mind. And my wife said, you don't know so much about these companies, people, what they're doing. Are you sure this is going to be a good idea? And I said,
it's Google.
It's exactly. It doesn't matter.
I want Google on my resume.
Give it the time. If as soon as I get Google on my resume, I can go whatever thereafter. And that turned out to be true, because we have in Sweden, people have a very high respect for these strong brands.
Yeah.
And
I can't understand you.
Nowadays, it's not so hyped, but back then it was really, really hyped. It was almost ridiculous. When we went to parties, I didn't tell people where I was working until explicitly asked.
It was so hyped right then.
Yeah, it was ridiculous. So I ended up working with video conferencing, and the product they had, it was more of an acqui-hire than anything else, so that eventually got sunsetted. But we built the first version of Talk Video, it was called at the time, that eventually became Hangouts, and now there's the sort of third generation.
This is the first generation of Google Hangouts.
Yeah, exactly. And I have never been passionate about video conferencing, but that's fine, because I ended up in the engineering productivity organization, and it turns out that Google's engineering productivity surpassed anything that I have ever seen before or after. So it was really educational.
So it's a little bit. This is the best school of life.
That was a very, very good school. Yes.
So this is interesting. Let's do the whole resume, but it would be interesting to take it as a separate segment to talk about what was the real standout topics here. But I think we should go to the resume.
But just very quickly, at least, what does an engineering productivity department do, or what's what their goals?
Tooling and processes for ensuring that the people are productive. It changed name actually from test engineering, because most of the activities were around like automated testing and automation of quality assurance and so forth. And that is no little thing at Google, because every line that you check in is tested not against your product only, but against everybody else that is dependent on it.
So this is true data product thinking, or something like this, that it really needs to run or be reusable. That's what I'm trying to say.
Yeah, exactly. And the Google is very, very coordinated. At least it was at the time. I haven't been there in a very long time, so I don't know how it has progressed. But the philosophy was that you move fast because you have the machinery, the coordination to and.
So we are truly talking about industrialized factory thinking at the core.
Absolutely, yes, and minimize the latency from your idea to putting it in code to getting it in production. They didn't do like pure continuous delivery and continuous deployment at the time. I don't know if they do nowadays, but there were release cadences. and so forth. I think that to some degree, for economical reasons, the number of tests that you have to run in order to throw out a release, with all of the performance regression tests, that amounts to a significant amount of money. So in smaller cases, in smaller settings,
continuous delivery
you can do continuous deploy. Yeah, exactly.
But this is a different scale.
And the economics are somewhat different. And there was also a culture shift, and that is really interesting because when I joined, the company was in this transition from relying heavily on manual testing, in particular for the mobile products. I mean, this was before the iPhone. But also with the web products and Selenium, I think technology like this was fairly new. And there was still a lot of manual testing, and it was decided from above that this doesn't work out. It's just too costly. So they said, in typical Google way, figure this out. Engineers, go figure this out. Yes.
I mean, testing is certainly a topic that's interesting, and I know you work at Spotify, and we had a lot of discussions there as well about what the proper level of testing, etc.
But let's finish the journey of Lal. I think this is an extremely interesting journey, and I already have 3 or 4 themes that I'm biting my tongue not to jump into.
That's fine.
So from Spotify,
from Google,
and
then
Google, I left when I felt that I couldn't learn so much anymore, and there was no other project available in Sweden for me to work on.
So the next step in Google would have been Zurich or
but
US.
Moving was not an option. I just had my first child and so forth, and not an option. So I joined a startup in a fairly early phase. It's called Recorded Future. They're now fairly big, based in Gothenburg. So I was one of a few people based in Stockholm. That was interesting, educational, not my cup of tea in the long run. I moved on. After a while, I was a bit tired of chaos and sort of sometimes the lack of like craftsmanship in software. So I decided to go to fintech to see if the amount of money in the area would actually make people care about quality. It did, in a sense that the customers were paying a lot of money. So when we did bad releases, they were very angry and they came flying over. On the other hand, the fintech overall is quite far behind in terms of methodology and processes and so forth. So it's kind of all evened out. I moved on from there to Spotify when I realized they were doing interesting things with data.
Did you get picked up by Spotify, or did you pick them up? How did that work? I'm just curious.
I said yes when the 10th recruiter called. So they actually called me twice after I had started working there as well. Somebody suggested I should ask what kind of salary I could get. Anyway, and the reason that took me to Spotify was really the data, because one of the realizations working from Google was how much value you can get out of data. Back in 2007, they were the only ones that did what we call big data today. And it was so evident that, yes, you could like dominate the fields that you're in just based on what you can do.
Could you feel that with Spotify? What made you feel that Spotify was on that idea?
So I went to, I think Meetup had started in town at the time, and Spotify was holding Hadoop meetups and Cassandra courses and so forth. So once they started saying Hadoop, I realized they were doing interesting things with data. So I wanted to go there, and I ended up in a team that called Analytics Computation. So there were just a few teams doing data at Spotify at the time. There was a data collection team and the computation team and some recommendation teams over in New York. And then there were some...
what year is this?
Analytics. This is 2013. And
where were you there?
I think it's about the same year at the start, actually.
Yeah, I think so.
Or
quite the same.
It's about the same year.
Same age.
And but the Hadoop cluster was, I'm not sure mature is the right word, but aging at the time. It was installed way back in 2007, so it had grown quite a bit. It was, tens of petabytes or something.
We're talking Spotify was on the Hadoop train 2007.
Yes. And that was a stroke of luck. I think that was just, out of pure curiosity. This seems like to be like a fun idea. But that cluster is I think the most valuable computer system that I have ever seen. It has generated so much data value. I think it started in 2007 in a closet at Jon's department or something.
Yeah, Jon.
It's Jon friend.
Now you're being
a person at Spotify was there from the beginning.
In the closet, I love it.
And when the sun actually hit the cluster, it actually overheated. So then it went down, and they had to.
Wow, this is Spotify war stories. I love it.
Exactly. I have a collection of those war stories, but at larger scale.
But we need to talk, let's not do it now, but we need to talk about moving to cloud at some point. That's an interesting story.
That's also interesting. I think that the Spotify's journey with Hadoop, I'm going way on a tangent instead of my resume here as well, but it was really a stroke of luck because early adopters of Hadoop have done really, really well with data. And I think there are two factors here. One, they are very technical companies and amenable to like adapt to things and so forth. But it turns out that Hadoop at the time could do very, very few things. It could store files. You could do batch computation with MapReduce, and you have this NoSQL database. And when you only have those things to work with, and you are kind of forced to because you're at the data scale so that you're forced to use Hadoop, what happens is that you are forced away from the
siloed.
Yeah, from the silos of the databases, because the Hadoop cluster is really expensive to maintain. You need a couple of people full-time, so you only want one of them, which means that you share all the data. And
you're forced to transparency.
You're forced to transparency. So, and because the security model is so bad, it's like readable to everyone as well. Whereas if you were in an Oracle database, you have very good security models, so you can lock down the data and you can keep your silos, right? So you achieve data democracy because it becomes transparent, and also because of the limited ways of computation that you have. You are forced to make to adopt the functional processing mode. You cannot no longer work in databases with mutable data where you can change a record at the time. You're forced to adapt like the functional paradigm because the data is in the files is immutable. So you have to build these transformations step by step that we now call pipelines.
So basically, in a way, what is the shortcomings of Hadoop at this point in time in order to cater for the big data value is fostering a data-driven company, which is at the essence all about data transparency, and it fosters a coding paradigm, which is the functional
and the functional architecture.
The functional architecture.
That you do this processing in jobs that process files and so forth. And because they're all immutable, everybody can share them. You can't share a database because you don't know how the others will change the data, but the immutable stuff is easy to share.
So in a way, growing up in this context actually already here puts you on a different path, how you understand data products, what a data mesh could be, all this.
And Google and this was like my introduction to data. So I've never been good at databases. I still can't type SQL, right? I'm crap at it.
That's not really true. But okay.
That is, you've never seen me. I can do 4 lines and then I'm lost. And so by stroke of luck, you were forced into building a factory instead of having your database as a pet. Right.
So this is really interesting because it really means that people growing up in the traditional relational database growing up with those habits and what is best practice in the relational database, they actually have a really hard time moving on to the factory thinking now. And this is maybe one of the key challenges why the enterprise has a hard time to truly become data-driven.
Exactly, because they have well-established practices that they don't easily change, right? At high-tech
but for this, the wrong practices, maybe.
Exactly.
Good for relational, but not so good for factory.
And if the late adopters of Hadoop, that have lots of money, they have gone to the Hadoop vendors and say, well, we understand this Hadoop thing is great, or nowadays these cloud things are great, but we kind of like to keep our workflows and the way we work. Could you please implement SQL and transactions and so forth? And then they are eroding the whole value, which is to force you into better ways of working and better ways of collaborating. And that's the real value of big data.
I mean, I think this is an interesting topic about, in general, about parallel computation in different ways. And it can be a big data setting, it can be in HPC, as you have worked in as well, or it can be in AI, which I would argue is all three different ways, but all have something to do with parallel computation. But before we move into that, I can see you being a bit questionable. Okay. But yeah, that's an awesome topic of discussion, I think.
I will continue to throw fire on this.
But before we
derail his attempts to control the flow here.
But let's try to finish up a bit about the personal background as well. So you worked at Spotify for a number of years, right?
And one of the core things we did there was when I came there, it was you needed a lot of folklore knowledge to put pipelines in production and so forth. So one of the first things we did was to do what is today called data ops. Like we went to a workflow with continuous integration, continuous deployment, and so forth, and like enable the whole organization to build pipelines rather than just a few teams. And that then data use like skyrocketed after that in the following years.
So was that like a deliberate strategy that you understood, or was that just something that evolved out of?
It was a fairly.
How did you? Because in this way, I mean, like I've seen you talk about data ops, and then someone said IBM did it, and I retweeted something in LinkedIn, like, hey man, this is way, I've heard this from Lale many years earlier, guys. Come on.
So
how did you get up to this?
Well, the concept didn't exist. I think the term was invented in 2014, and this was 2013. That is what best describes what we did. It was a fairly low-level decision, if I remember correctly, and we were just being swamped with requests from other teams to do things for them. And it's a natural progress for an organization to have these experts, consultant data teams in the beginning, but then sort of try to democratize later. So we felt that, well, we just enable everybody else instead.
So it becomes a data serve model. Is that a way of putting it?
Yeah, not data serve, but sort of self-service for development teams to build pipelines and to do so without coordinating with the central team, sort of central data teams. So it was an evolution of the data platform.
A survival, as it sounds at this point.
Something like that. We were being swamped. Anyway, I should go further because I just want to mention that because that has been my mission in life since, like enable people to get value from data.
Good mission.
I moved on to Schibsted, a former manager at Google contacted me and said, we're going to build a central tech organization with a central data platform. Do you want to come here and like architect the data platform for us? And Schibsted is not so well known in tech in the tech world, but there were like all in all with all the clones of Blocket and all of the newspapers that they own and so forth, there were like 200 million users who were generating data. So that seemed like an interesting endeavor, right? And it was a way to sort of I reckon it had like a 10% chance of creating a Scandinavian internet giant. And if I got the chance to be in early on that, I wanted that chance. And we succeeded extremely well in recruiting really good tech people. But nevertheless, we were not set up for success. So it has they have picked apart this organization after that. There were lots of interesting tech were being done, and it was a very educational journey, but it eventually collapsed under its own size in a sense.
This is another very interesting discussion about centralized versus decentralized
and organized and all that. So let's also park that in our head. we will have 3 hours today, Anders. I think.
Exactly.
So I moved, after a while, I met some really good people there and learned a lot from doing things with the greenfield. But I went on to become an independent consultant and. With the mission to help organizations get more value from data. And I've had a wide range of clients, some weird startups, some AI and other things. I've been back at Spotify a couple of times doing consulting, which is interesting because what you planted a couple of years ago, you can now see how it has evolved and so forth. So that has been very educational. And I've been at a number of banks. I spent a significant time at SEB, for example, when they were doing a sort of a big data project. And my last and most successful engagement was at Bonnier News, so Dagens Nyheter, Expressen, Dagens Industri, half of the major Swedish newspapers, the half that's not Schibsted. And that was interesting because by then I had realized that many of these big data efforts are like suffering from way too much complexity. There are all of these piles of technology toppling over each other. So I had the trust of the CTO and the sort of the lead architect at the company who was our champion, and I got the opportunity to build a platform there for data processing by scaling everything out that was not necessary. So we did the simplest possible thing, but implemented the sort of the important workflows and the democratization of data and getting things working and so forth. And when you see these sort of big Hadoop project or big data efforts on the large companies, it takes 6-9 months up to 2-3 years to get them into production. Like from the day that I walked in, had a hand like 3-4 people to work with, to the moment that we had a pipeline in production and a client, an internal customer who we had to find first, that said, yes, this saves a lot of my time. This is very valuable. That was 3 weeks. Right? Mm-hmm. And then that is the shortest I've ever seen from nothing into production.
But I know we have talked about this before, and we can also come here, but this is one of the key. Simplicity, reduce complexity is one of the key topics. And I think going into even how you measure KPIs, how many pipelines can you put in production per month is a very interesting metric that not very many people do.
Yes, I can rant about this for a while.
Let's get there later. Yeah,
but let's go there later. Yes,
because now we are sort of getting here, and now I guess we are soon arriving at Scling.
Exactly. So after this, I'd hooked up with an old colleague from Schibsted, and we said let's do a startup. And to some degree, this was a reaction on I have so limited power to actually enable these companies because they are hindered by their own ways of working, their culture and their organizations and so forth. I think we can have more impact if we do something externally. And during my freelancing, I had contact with a number of large Scandinavian corporations, either direct or indirect, hearing from others who were there, many of them in the Wallenberg family. So I heard directly or indirectly from like Atlas Copco and Electrolux and SKF and Husqvarna and so forth, right? And the impression that we got was that they want to buy big data, right? Nowadays they want to buy AI. Get a box, unpack it, put it in a rack, turn on the power, get a service agreement, and so forth. And now we have AI or we have big data, and that makes we can laugh at it, right? But it makes perfect sense. It's not their core business, right? So it's not so easy to just flip the company over and become data driven or AI driven. Why can't it be a commodity, just like power or electrical power or commuting or computing nowadays?
I think it will be at some point in the future, like big data or AI or HPC.
To some degree, lots of exotic computing things that we used to think were weird, like internet and data, so is a commodity today, right? Yeah. So it's not a weird thing to think. So we scratched our heads and we said, okay, how can we supply this, right? What I've seen, the ways for the if you're a super technical company, then you're self-sufficient. But for the non-super technical companies, which we have lots of really good companies that I would like to help. For them to tackle these things and get these superpowers of data and AI, like how can they do this? They have it's a fairly short menu today, right? They can hire consultants, which can do customized things for them. But you have in order to hire consultants, you have to know really well what you want, right? And that works in the construction industry because it's so well established. But as a buyer, you are not competent enough to buy the right things. And the incentives are wrong because the consultants really have strong incentives to build very complex things and topple all of these technologies on top of each other so they can
stay forever and make money on the licenses.
Or show off for their next employment or whatever, right? And I don't think that the consultants are bad people in any way, but the incentives are set that way, right? And that changes people's behavior. So,
but it's not only the consultants; it's the whole the vendor licensing models and how you want to get people into the one and same universe, good or bad. There's many dimensions here that the whole industry together, vendor, consultants, recruitment, brokering, I think they're all moving in the wrong. Together, it's actually a bad spiral instead of a good spiral. That's what I hear, and I've been on the same path. Is the industry set up where it should be?
Yeah, that's a good question. That brings us to vendors, which is one of the other options on the menu, right? Particularly if you have a relation with like IBM, Informatica, Oracle, SAP, whatever, then you can say, okay, what's on your menu? What do you offer? And okay, we now have this deep learning this or web analytics that and so forth. And then you sort of trust the vendor and you ride along with them. Now there are good, there are benefits, there are pros and cons here. One of the cons is that these are not the ones driving the innovation today. Nope. If you go to the technical conferences, they're completely dominated by the high-tech product companies and the cloud vendors and open source, essentially. Exactly. So what else can you do? Well, you can find specific solutions to niche problem. You can, get your web analytics things from Mixpanel or Google Analytics, and then you can get your deep learning things from Peltarion, and then you can get your BI things from Snowflake or Power BI or something. And then you solve problems in a siloed manner.
And where's the factory?
Exactly. You don't get a factory, and for those problems, if you have a match, then that's usually efficient. But you don't get this bottom-up innovation that we see when we democratize the data. So there are pros and cons here, and I think none of these options are even close to matching the value that we see in companies like Spotify or Google in terms of creating value from data. Yeah. So I firmly believe that we need to find new ways to collaborate.
Is that the the idea of Scling or
Scling is the pronunciation. Yes.
Yes. Is this short for scaling or what's the origin?
It's a reuse name. I'm very environmentally friendly. So it was actually a name for an earlier startup that never left the hobby phase, and then it was a combination between that was a natural language processing idea. So it was a combination between science, language, Ling as a language, and scaling. I like short names, and it's very hard to find a good name where the com domain is free.
Right, true.
So I was tired of finding names, and I got some.
So what's the core idea now of Scling? Let's go there.
So
what's the core value proposition?
The core value proposition is to extract value from data on behalf of our customers by collaborating closely with them. So you remember the arrogance which we spoke about earlier between the domain experts who think how hard can data be, and the data or AI experts who think how hard can a domain be. So we want to respect both of these competencies by collaborating with the people that have the data and the domain knowledge and work with them. And if these companies that we turn to, if they were technical enough and had the volume to build their own data departments and so forth, they would and perhaps should do that. But so we are an partnership alternative to building your own. So when companies think, hey, maybe we should hire this chief data officer and let him build a team of 5, 10, 20 people, that we are an alternative to that strategy.
So if any company wants to start or really get bootstrapped into the data journey and becoming data ready in some way, that could be an option to turn to you and Scling.
Exactly. And the way it works in practice is that we set up flows from their system, from their databases or their Google Analytics or Salesforce accounts and so forth into our own platform, which runs in a major cloud. And we build together with the domain experts, build these data flows and data pipelines and so forth. We run them, we operate them, we host them. And it's a refinery. So we get raw data in and we produce refined data.
But I think, can we segue now into the next theme a little bit?
Yeah, if it's the right theme.
No, but because here I think this one of the most interesting thing with what Scling is doing is actually, in a way, trying to understand where is the future type of alternative business model comes and going, or where are we heading when it comes to data, and even to the point where we talk about data pipelines as a service. And I find that super interesting to explore a little bit because, a lot of companies, it's not only about the complexity, it's also about, I have a CapEx constraint, I have an OpEx constraint, I have a full-time equivalent recruitment constraint. So I know a bunch of companies, they got the money, but they are not supposed to recruit anymore. So as a service, and we need to buy this as a service, is very interesting, and it's done quite elaborately in different fields. And here we now have Scling as a service, data as a pipeline. So how did you, so this is sort of, I think this is new territory, to be honest, right? Where this is going and how it could evolve. But I think it's also something about, is the consultant, is the whole industry, the way we are tackling this, is it the right way, or are there other ways? And I think Scling is now really exploring new territory, which I think is cool.
Yeah, for good and for bad. We definitely are. And the only thing that I'm convinced of is that we need to explore new territory in terms of ways of collaborating and business models. And we are small, so we explore one variant, right? And I'm sure that we will slightly pivot along the path and find new ways of interacting with the clients, depending on how technical they are and which domain they're in. And I think we will need to experiment with the business model. Today we have a value-based business model where you pay for the value that you get out of it in terms of pipelines rather than paying for hours. But that is difficult to sell because people know how to buy hours, right? And they know how to buy software as a service, but they don't really know how to buy value in a domain or in a tech area that's new for them. So sometimes people ask me, well, what don't you need to move faster and expand faster and so forth? What happens if one of the big consultancy giants adopt this model? And I think that will be great, because then we can point at, look at them, Accenture or Tieto or whatever. They're doing this. We're doing the same thing, but here are our credentials. Then we are competing with someone, and that would be perfect, because that would help us explain the model.
To some degree, we're exploring new service categories.
Exactly, and that turns out to be much more difficult than the technology.
Yeah.
Okay, so let's try to move into a topic that I think is rather interesting, and I know you worked a lot with in Spotify as well, who made the journey from going from on-premise to the cloud, which was a multi-year, endeavor, and took a lot of time and money and effort, and they did a lot of mistakes, I think, but still, made it. So what would you say? Let's say that we have a company today, some Swedish company that's getting a bit threatened perhaps by Amazon moving to Sweden, and perhaps it's a retailer, perhaps it's some similar company, and say, we really need to get, data ready now. Should we move to the cloud or not? What's the first answer you would say to that?
Moving to the cloud is for a purely on-premise company that does not have the experience of managing the cloud is a significant undertaking, right? Yeah. And I don't. It took, how long did it take Spotify? A couple of years?
5 years, I think. Or
something like that.
I think they still have some on-prem stuff, but it's
maybe.
So what was the rationale for Spotify to go to the cloud?
Focus. Spotify is very focused on media, period, and audio media in particular.
We don't want to run data centers.
Exactly. So it was a way to focus on what they're good at in their business and so forth. That was a strategic explanation. And running data centers and all of the low-level nitty-gritty stuff has a significant cost, a massive cost in terms of people. And when you're constrained by if you want to grow and you're constrained by people, that is very expensive. I would claim that long term there are also security aspects here.
Benefits.
Yeah, definitely.
To go to the cloud.
Absolutely.
Because it's interesting. Everybody says, "Oh, it's scary to go to the cloud," but the people who know says, "No. This is naive to think you're more secure than a supercenter of AWS or GCP or Azure or."
Yeah, the people that say we need our own data centers because they're secure, then you go and look at their security practices and then you cry a bit.
Exactly.
I think it's going to be, fast forward 10, 20 years, it's going to be completely obvious, and we are going to look at how blatantly naive we were with running our own machines, and having these machines that haven't been rebooted in 2 years, right? If you get a foothold in one of those machines, you're in there forever, right? As an attacker, right? Whereas the containers we run in the cloud, they live for hours and then they go down, and so even if you manage to crack something in there, then you're killed after a while. So you get much more information.
So I think this is all interesting, because the naivety of IT security, we look at one thing and we look at it's a little like filtering mosquitoes when not really looking at the fundamentals like this.
Yeah, absolutely. But coming back to your question, should we go to the cloud? Security is also one of the main challenges, because whereas the cloud can be much more secure than on-prem, the security paradigms and models and techniques and knowledge that you need is completely different. So all of the competence that you have running on-prem is not necessarily valid on
And just for
cloud.
people that don't really understand, what cloud computing is about and what the difference is to actually having your own hard drive you have to manage or operating system you have to manage and whatnot. Some people, try to describe this perhaps in a bit simplistic way of saying you build different level of abstraction, saying, you don't manage your hardware, you don't manage the operating system, you don't manage the application, and you continuously move up this like ladder of abstractions. Do you think that's a good way, or how would you describe, the move or what cloud computing is all about?
Yeah, first and foremost, cloud computing is somebody else's computer, right? It's something that you rent rather than you buy. And then there are different ladders of abstraction here. And from the low level, infrastructure as a service, where you have your virtual machines and your networks and so forth. They're virtual, but they work the same. And I've met companies that have a data center in the cloud. They have all of these virtual machines, and then they control the routing with OSPF and standard routing protocols between them. And in a way, as a transition, that might actually make some sense.
But then this is a data center virtualization. This is a data center business case.
Yeah, rent a data center essentially. But that can be one iteration towards going full cloud. At Spotify, we call that the forklift, right? We just took what we have and put it on virtual machines as one step.
Lift and shift.
Exactly. And so let's see, where was I?
Abstraction. What's next?
Yeah, and there are many abstraction levels. Like then there is the platform as a service things. Right? You don't run MySQL yourself. You ask Google or Amazon to run MySQL.
But you code on SQL.
Exactly.
Your app is yourself.
And the APIs are essentially the same. And for these low level things, the only difference, there is no difference as a developer, but there is a difference as an operator, and there's no difference as an application developer, except that you probably are also shifting at the same time to the DevOps mentality, where the developers sort of own the infrastructure. But the difference is in the control plane, because instead of wiring physical things, you wire things with API calls to the cloud, and you use tools like Terraform or Pulumi to sort of wire things up instead. And that is a significant difference in terms of how you operate things, and also in terms of security, because these control planes that are given by the cloud are very tightly controlled, and some of the things that you can do with them you had to do over the standard network in your on-premise environment. So you would have to SSH into boxes and so forth. And that is much less secure than using the cloud's control plane to control them instead of sharing the control and the data plane.
So the cloud is more than just having or not having to manage the hardware. It's actually also managing other things like the software as well, the operating system.
Yes, and then there are higher layers.
So now we are IaaS,
exactly.
PaaS, and let's now go to SaaS.
And then we have container as a service as well, where you just ask a container to run somewhere, and then a function as a service, which is in a way to resurrect Java beans. Or stored procedures, and then. At the top, you sort of have the software as a service, which G Suite and so forth, which is completely non-technical. Yeah, and then there are hybrids here as well.
This is an interesting question, and of course we know there are a couple of leading cloud providers today, and they're clearly leading. I mean, there are many of them, but I think there are 3-4 American ones and a couple of Chinese ones, and there are a large number of others. But do you know of any kind of European cloud providers that we have today?
There's Amazon, there's Google, and there's Microsoft, and then there's nothing, right? And even if you go to the sort of the second tier far below, I don't know what Alibaba has, but I think that's impressive. But otherwise, it's all American. Right?
Do you think that's a problem?
Yes.
Why?
Because, to be honest, we don't. We are completely dependent on cloud on these major cloud providers today. If we were to not use them, we are at a significant disadvantage
to the rest of the world,
to competitors that are in the cloud. In particular, if you're doing high tech or startups and so forth. And there is no cloud provider from a European perspective, trustworthy democracy and justice system today. And I mean, we've seen if you look at the democracy index, the US has been steadily falling there, and we have the privacy shield that was considered not new now with their Schrems 2 case.
So what is the privacy shield? So what is that all about, and what does it really mean for everybody who's using American?
Good point. So GDPR puts a number of requirements on how you handle personal data, right? So it allows you to store data at other providers. Then if I have a company and I take your data to do something, maintain your Tamagotchis or whatever, then I am the data controller. I have a relation with you. And I can use other companies, and they are the data processors. For example, I can store...
so we are referring actually to GDPR roles now. Data controller, data processor.
Exactly. And and I make, by taking your personal data, I make some commitments to you, right? I make some commitments that I will treat it securely and not allow anybody else except my data processors, which I enumerate, to handle these data. And I make a commitment that if you want to delete your data, I will go to wherever it's stored,
and I have processes to do it within a certain amount of time.
Exactly, and so forth, right? And that means in relation with my data processors, I must be able to enforce them not to share it with someone else and to delete it and so forth. Now, if we're here in Sweden and this is a data center company in Sweden, everything is fine because they're under Swedish law, and any European Union company, this is fine because they all respect this law and so forth. But after the Patriot Act in the United States, the U.S. basically says that U.S. security interest trumps these things, right? And then there was an agreement called the Privacy Shield, which stated that all data under the GDPR essentially is we will respect those laws, right? Even if you store these this data with an American company, we will respect these things. And now with the recent case that's called Schrems 2, I believe Max Schrems is a German privacy enthusiast, I think. It was found in EU court that this is insufficient. The guarantees that the Privacy Shield gives, along with the U.S. Legal system, the U.S. jurisdiction, is not sufficient.
And when was this case published? This is like a month
ago or something. Yeah. So it's very recent. So right now everybody's like ducking their heads into the sand. And pretend that it didn't really happen. But long term, this is not sufficient, right? Either the U.S. jurisdiction will have to change so that they prioritize the...
They need to respect, in some ways, European law if they want to be providers to Europe.
Essentially, yes. And sort of promise that the NSA will not go and look at your data without due process, basically. And I don't think that's going to happen anytime soon.
So let's flip it. What will it take, or what would be the smartest strategy to get a solid European cloud provider? How would we go about fixing that?
I am afraid that I don't have an answer. To create something that compete with the three major providers is extremely difficult, right? It requires a huge
let me dig a bit
investment
deeper
and so
into that
forth.
question then, because one way to talk about this is to say you can do a top-down approach or a bottom-up approach. And what I mean with that is basically top-down means you do the Chinese way, basically saying the government saying, decide exactly this is the way it should be done, and you pour money from the government into building up an infrastructure or whatnot. Or you can take a more bottom-up approach saying you have the companies and they will actually build up something and you will rely on the market that they would actually come up with some kind of solution that works for it. What would you say? This is a difficult question, of course, but what would you think would be a good way in Europe to actually have, at least at some point in the future, some cloud provider that is getting closer at least to the top cloud providers?
Yeah, I don't think a top-down approach is viable. I think there will be attempts at this, but shaking up vast volumes of money, I think is possible. But shaking up the competence to build such an organization, both in terms of leadership and technical, and then get the trust to actually get the volumes of customers that you need, I don't see that happening.
What's the problem?
Well,
competence.
Yes, on so many levels, and an understanding of how much we don't know and don't understand about how the cloud providers actually work and what they have inside that enable these capabilities. I've met lots of people that think, say, how hard can it be? Or we have a good startup here. If just give them a bit more money, they will create something fantastic. And I was like, you are so many levels down on ignorance, right? It's not only that you don't know what it's about, you don't know what you don't know, and you don't know how to figure out what it is that you don't know.
I think this is an important point. People think that, we can just build up an infrastructure in Sweden by having a cluster of some machines, and you have some GPU machines, and then we have a cloud in Sweden, and awesome. And they don't really recognize, right, all the software and levels above that is necessary to come even close to what the cloud providers have today, right?
Yeah.
But let's now. You worked at Spotify, so let's really. So we say that, but could you give a couple of examples? Because we are already on it already. That already when you worked at Spotify, it was clearly a factory and industrialized approach. But could we give some simple examples or way to make that more tangible? Maybe it's like how you say they have structured process. Indirectly we can hear it. They have testing, they have everything, right? But what we are saying something is true, right? They have so much depth of this competence of what they're doing. But is there any way to make that exemplified or tangible so it becomes more concrete for the people who's not in the know? Maybe it's from some of the examples that you had from Spotify.
I'm not sure. Let me give you one example from Google instead.
Google, I meant. We talked about Google. Sorry. So
Google has a vast amount of code, right? But they also have lots of products, so it's no surprise. But if you look at these diagrams of how much code different organizations have, Google, Facebook, Audi, Linux kernel, and so forth, and like Google is way beyond everybody else. If you look at how much of that code is touched each month and changed each month, what do you think the answer would be?
I actually think they're grooming it all the time, if I understand you right.
50%. This number is a few years old, but nevertheless, it's the same, right? And if we look back at Spotify and what would it take Spotify to be able to touch all of the half of the code we had in 1 month? We were nowhere near that, right? We didn't
Spotify
have the machinery.
Is like the superstar in Sweden,
exactly,
but nowhere near.
Exactly.
And that's a good example.
Yeah. And you could see, when I work at Google, you could see these changes. Here's a change. It touches 5,000 lines of code. And it was like, what? 5,000 different files. And how could any human possibly do that? No, it was, these bots that went around and changed the code. And if you rolled out changes like, these routines now should take a new parameter with an authentication token or something like that was rolled out within days.
So what
automated refactoring.
So you're saying there is a lot of stuff as part of CI/CD or however you want to call it that is automated, that is happening, that really has this sort of factory. I changed this, and then it's no humans going around and changing those, 50% of the code. Yes. It's bots doing it.
And we are only very recently seeing this in the wild, right? There are these bots, for example, that go and submit PRs to GitHub with security changes and so forth. This is like 15 years later, right? So I don't see any company or organization in Europe being able to catch up with that. That's not realistic. So I think your view of a bottom-up approach is more reasonable, and if it needs to be open. Otherwise, it's meaning. Otherwise, we can't do it bottom up because we need to have.
It's really open source stuff.
Yeah, and I started thinking along those lines when you sent out some preparatory question the other day, and I was like, yeah, maybe something open source standard. It sounds like a lot like OpenStack, right? But that has the wrong smell, and it never took off for good reasons.
What is OpenStack?
Oh, it's a open source. Like pile of different projects that are similar to the base cloud things like virtual machines and object stores and so forth with a standardized interface. But it has this, many jumped on it, but it has this enterprise smell that isn't right.
But maybe there's another strategy that like you can't maybe compete on this generalist view. So maybe you need to be more niched. Maybe you need to figure this out. European style is different, that you don't try to compete head to head, but you do a niche strategy. So transportation, energy, and you get the de facto standard cloud setup energy with the de facto standards on even protocols and I don't know. I'm used.
Maybe. And maybe we can take inspiration from how the internet succeeded, right? Which is a very federated, decentralized thing. And maybe there's something similar, but running clouds is all about, it's very operationally heavy, and that's the operations is like the real value of it. Somebody else running.
If we try to summarize that, I think we can all agree that it is a big difference between the tech giants of the world and the rest of the companies in the world, right?
Yes.
And yes. I don't think many people understand
how big
that difference is. No,
right.
It is huge.
Yeah.
I think if you look at any company and you ask them to do a spider diagram of their capabilities, and you say IT here and logistics there, and take different dimensions, they will all give themselves, we have a 5 and 4 or 6 on a 10 grade scale, and they will think that they are like quite good at everything. Whereas at least in IT, the reality is not at all like that. There are the companies that are best at something. They are decades ahead of everyone else. So everyone else, all companies, even them, all companies are like at level 1, except for in something that they're really good.
Yeah, and to not become too depressed about the current situation. I mean, we know they have the tech giants, and they are very far ahead. But if you instead compare countries with each other and think like the average kind of American company or average Chinese company to the average Swedish or European country, what do you think the situation is there?
I think that we have some unique strengths that are different. Yeah. I think if we go back to the spider diagram, we are really good at some things. Yeah. That the American companies are not so good at because of culture or different things. And that was a realization going from Google and coming from Spotify, because Spotify is not so great at the things that Google are super, super good at. But the weak points in Google, Spotify is top
Can you give
world.
An example of
that? Getting the most value out of a team of people. That is something that Spotify really excels at. And Google's approach to it was of course, scientific. They eventually ran these different measurements of how people work together and so forth. And it was called Project Aristotle and something else. And,
I read that paper.
And took a scientific approach and said, what is most important? Is it the people we recruit? No. Is it the different programming languages? No. Skills? No. It turned out to be psychological safety in a team, right? Allowing people to be vulnerable. And what they described is, this is Spotify's company culture, right? This is very natural for Scandinavian companies. And it took them like a decade to figure that out.
We have some kind of culture in Scandinavia that is perhaps very valuable.
And there's a lot of trust, and there's like team before individuals, and being part of a greater whole. So, if you look back, Scandinavian companies have been good at building like systems and things that connect together. I think that culture is part of Ericsson's success. I'm convinced, right? It's a big global world system. Yes, that fits the sort of Swedish culture, whereas detailed innovation fits the American culture much better.
I want to come back to the earth when it comes to cloud. So I want to ask a very simple question. Could you elaborate a little bit about what was the strategy and what was the process when Spotify went to the cloud? What was the learnings? What was the pitfalls? What would you have done differently? So tell us a little bit about your experiences from moving Spotify to cloud and what your role was.
There are some excellent YouTube videos by Ramon van Alteren and Josh Baer on this topic. They were much more involved. So I mostly saw it from the side because this journey started after I left as an employee, but I saw it as when I came back as a consultant. So it was a very much iterative approach. You cannot do these things big bang. So for the data part, it's fairly easy or relatively easy because you're all offline, right? So if you go down a little while, nobody gets immediately affected. If you think of things like login services and playlist services, they cannot be offline. It has happened, but that's a significant outage, right? So then they had to be much more careful and setting up parallel databases, and those were almost exclusively forklifted. So they would set up a Cassandra cluster in the cloud to host just a few employees in the beginning. Since Spotify has always been since way back been multi-data center. So then taking the step to be a data center in the cloud is in a way fairly straightforward because it's just yet another Cassandra cluster. But you have to, there are a number of assumptions that you have to validate with in terms of quantitative assumptions and performance and network bandwidth and latency and so forth. And that are no longer valid if you don't control the machines all the way down. So my understanding is that was quite a bit of work in those areas. But the whole process was decentralized. So all of the teams were expected to at a suitable time
figure out their own journey. And Spotify has an interesting way of prioritizing and managing these sort of strategic efforts. This sort of the sequel to the Spotify model. It's something called DIB. I don't know if they still use it, but they used it at the time. And there was a way to drive strategic priorities by the central point of this is a fully transparent, prioritized list of all the company priorities. So we in the past there have been things like become GDPR compliant and launching in Japan and things like this, and those things all have a specific priority, and only one is the top priority. And at the bottom level, you say you might be working on something with priority 2 or something, and then you need help from another team, and you go to them and say, "Hey, I need you for this. We're busy," they say. "And what are you working on?" "Priority 7," they say. "Okay, put that aside. We have priority 2 here," and that works very beautifully in a way to like
move strategic things forward in a fully decentralized and low friction.
Very interesting
manner. So moving to GCP was one of the things that popped, up and down on this priority list, and that's how they control the speed of that move.
Cool. I have some other topics I'd like to move into, and one of the interesting, I think, unique knowledges that you have is that you've been working with HPC and you've been working with AI, you've been working with big data, and I know we even sent people from Peltorian to your course in big data and things like that. And you are an authoritative, so to speak, in these kind of fields. Let me make a statement, and you can disagree and have a discussion about this. But I would say, I think a few people understand the difference or the problem with moving from having an algorithm, whatever it is, running on a single CPU with a shared memory, into moving into, let's say, a big data setting. And there is a lot of work you have to do to change that algorithm, make it work in a parallelized setting. I hope you agree so far, right?
Yeah.
And I would argue that although that HPC and AI are different in terms of how the parallelization works and how the shared memory works, it's still the same problem if you want to move something to an HPC or traditional HPC setting and like a GPU-based AI setting. Would you agree with that as well?
Yes.
Yeah. Mm-hmm. Yeah. And speaking, as the big data expert you are, and having given courses from Rise and whatnot in this, what would you say the top challenges are in trying to have an algorithm, whatever kind of search algorithm and whatnot, and making that work in a parallelized fashion on like Hadoop, Spark, or something like that? What are the problems with that, really?
Okay, the first problem is why do you even do this in the first place? Mm-hmm. So the first rule of distributed systems is avoid distributed systems. So
especially Hadoop, right?
or any distributed system, right? So do you really have a return of investment in going parallel? Mm. And usually the answer to that question is no, for the vast majority of tasks.
Yes, right? Good point.
In many cases, you can let me back off a bit here. Let me tell you an anecdote. I was contacted by a Finnish startup, and they needed some assistance. They had some machine learning jobs or whatever. They couldn't get to work, and they used to work, but they don't anymore. So okay, what happened? Well. And there was some rounds back and forth. I couldn't figure out what they were doing wrong. And then they gave me a link to a blog post. Here, these guys have the same problem. The problem is S3. They had their data in S3. The S3 and Spark. Okay. And it turns out, when I read the blog post, I realized that there was this company. And every time they retrained, and every time they processed with all of the data cleaning, feature extraction, preparation, and then retraining, they were doing that on all history, but way back to like 2013 or when they started. And this worked great for a while and then became slower and slower and slower and slower, right? And we actually had a case of that, I think, at Spotify as well, which was discovered only when we moved to the cloud, because there were these people that were reprocessing all of the data since way back in time. And turned out they had taken like 10% of the Hadoop cluster and nobody ever noticed. And so they got help to rewrite their algorithm, not in a parallel way, but in an incremental way. So rather than processing the raw data, they would build a proper pipeline where you would clean the data one hour or 1 day of data at a time, and then get the features out and blah blah blah, and then only at the last step you need all of the data to do the retraining if you have a neural net, for example. Right. And this is something that I bring up in my courses as well as one of the examples, and say that this is something you need to look for. This is important. In that case, I'm showing, if you want to count the most popular songs by country or whatever, right? You can, that's a two-step algorithm, right? You can do first all of the counting of the songs to one data set, and then you can do the comparisons in the second set, and only the comparison do you need to redo. So the first level to parallelize at is on the workflow level, right? They figure out what steps you can do separately. And that's not parallelized with like Spark or MapReduce. That's parallelized with workflow orchestration. At Spotify, we use Luigi, which I happen to be fond of for these things. But there are others like Airflow, Dagster, and so forth nowadays. And this workflow, that's one of the most common mistakes in big data, not grasping and getting full hold of these workflow engines. I see so many companies that struggle with this, even companies that you think are fairly mature. That's one of the things that we really nailed at Spotify and became good at.
So instead of reprocessing all the data,
let's talk about this now, because but we're talking about some really important stuff here that, it's Greek to me, and I think it's Greek to a lot of people starting up with big data, and they have a traditional hat on. They've been doing data warehousing. So what are you talking about when you say you're breaking down the workflow? And what is Luigi? What is Airflow? What is workflow orchestration?
Those are good questions. So Luigi, Airflow, and so forth, we call them workflow orchestrators. They are basically the data equivalent of a build system like Make or Maven or Ant or Gradle.
What's their purpose?
Their purpose is to figure out what data you want to have processed, which you specify by specifying your the sort of desired data sets that you want out and the dependencies between them. So in order to calculate the most popular songs for this month per country, I'm going to need the data for each day during this month, right? So that's 30 basic data sets. And in order to compute them, I need to and do this in two steps. So I take the events from all of the songs, and I do that in one step, and per day count, do all of the counts per country. And then in the second step, I do it on a sort of monthly basis where I compare. So in the workflow orchestrators, we describe these dependency patterns. And anybody who has worked with software is familiar with this, in particular if you work with old tools like Make, where you say, I want this software artifact to be built. Nowadays, it's a container image, but it used to be a jar or an executable. And in order to do that, you need to build these object files from source, and in order to get this source file, you need to build this generator of source and so forth. So that's another type of dependency tree. And every time you run these sort of dependency management tools, they will figure out, well, I already run these tools, and so I don't need to do that again, and the information hasn't changed. So let me just do the last little piece, right? And any software engineer will expect these tools. And if you go back to when my dad used to work, that he would write scripts that did this from the beginning to the end, like 30 different invocations of the Fortran compiler. And because that was the sort of the state of art at the time, and it wouldn't care whether something actually needed to be rebuilt or not. It would just do everything from top to bottom. But now, fast forward to 2020, we still see many companies working in this manner with data. They have a script where they run everything from top to bottom and do that once an hour or once a day or something. You can make a factory that way, but it is very, very fragile, because if something breaks somewhere, your whole pipeline will break down.
I think this is talking about why big enterprises do not succeed with their big data efforts or getting value or getting really speed and all that. I think there's a fundamental misconception, and I think there's a lot of people who moved into this space that started in the data warehousing space. They started with the star schema ideas and all that. So could you elaborate a little bit about what is the fundamental difference in thinking here?
That gets us back to the factories again, right? It's thinking. If you go back a bit in time, or how many of the enterprises still work, they're still working with like craftsman's tools, and so they're working with the data equivalent of like hammers and screwdrivers, which is in data terms that's Excel or manually typing SQL, right? They have gone in some cases gone from that level to the power tools, the
data warehouse,
the data warehouses and Power BI, which is still a craftsman's tool.
But the power tool.
But they're powered by machines.
I'm using the electrical screwdriver.
Exactly, but they're still more or less steered by humans. And the mature data warehouses, they start to touch on these pipelines where you see the ETL flows running each day and so forth. But they are in general, when you work with them, you are in general not able to go back and correct things if they go wrong, because you don't have the flows set up so that you can easily throw out a new flow, or if you have a bug somewhere, you can't just delete and build everything from the beginning. They're still made to run on the daily basis and so forth. And that's why you have to do all of this modeling up front in the data warehouse with your star schemas and your satellites and your data vaults. And you have to think very carefully how you do to handle the slow changing dimensions and so forth. All of that thinking is unnecessary in a data lake environment, because you have the raw data, and if you do something wrong, you create a new pipeline and process it in a different way.
And just to wrap this up then, do we need both, or do you think carefully, like, why do we need warehouses? Forget about that. It's a different way of doing it. Just learn it. Or is these different use cases in the end where the data vault schema or the star schema has a place? Or you essentially say, rethink, relearn, and we can get to the same result in a different way? Where do you stand here?
The long term, and in data mature companies, the data warehouses have one purpose left, and that is for exploratory analytics. To have a sort of a prepared data workbench where you can turn things around. So you usually have hyperdimensional cubes that you sort of shift around.
So a lot of data. So you've created a super data set to explore.
Something like that, yeah.
But from an operational point of view, no.
No, not. You feed humans with the data warehouse, but you don't feed machinery anymore through the data warehouse. And reporting is, if you are used to a data lake, data platform, a data processing environment, or the sort of monostyle data factory environment, and used to data ops, doing all of the reporting and so forth, that usually in a bank lives in the data warehouse, that's easier to do in a data ops data factory setting. And in fact, that was
the reports.
That was one of the major.
So this is interesting. So you say data warehousing is not for reports. I like it.
I mean, if you look at companies that have had the data warehouse, yes, their reporting is going to be in that data warehouse for a very long time, for legacy purposes. And maybe it's never a good idea to shift. But when I joined Spotify, the technical username of that we used to access Hadoop was reporting, because that was the first purpose of the Hadoop cluster, in a sense. And reporting never left Hadoop, because it's so much better to do it there. And we
so this is really interesting, because we get the consultants, the management consultants, they're trying to build this storyline, and you are telling me, well, think about it, reporting can be done beautifully this way.
Absolutely. And that was actually a power in terms of business value as well, because I was doing royalty and reporting for a while, and the manager said, we're the sewer of the company. Everything that's ugly downstream, it floats and it ends up here, because we were one of the few teams that cared a lot about data quality.
So royalty reporting is this.
Because if you deal with the finance stuff, you care about the quality, whereas for recommendations, doesn't matter all that much. Anyway, so we had to do lots of like repairs of broken data, and that turns out to be a lot easier if you have a powerful programming environment. And at some point there was a renegotiation with the contracts and so forth. And the much of the royalty calculations and reporting is contracts with record labels translated to code, right? And after these renegotiations, they would come back and we would look at this and say, well, you actually, in order to ship the right royalties to these artists, you have to look 2 weeks ahead in time or something, but you're supposed to do that within 3 days. Like, what are you giving us? And most of the cases were simple, but some of the cases were really difficult to implement in code. And they looked nice on legalese, but in code difficult because of the data dependencies. And we used to swear about these things, right? And can't they have a software engineer on that negotiation table? But it actually then we realized, well, wait a minute, this is actually a very powerful feature. Because we saw some blog post of I think it was Airbnb's reporting pipeline, and we realized we were 5 years ahead of them in terms of being able to express things with reporting, and being able to express complex business relations was a feature that enabled us to get the contract signed, and that's what Spotify lives and dies with. Right?
It's a very interesting, completely different angle on the traditional BI versus big data story. And very interesting.
Also, if you look at reporting, which is reporting what has happened, if you take the same code and you tweak it a bit, it turns out that you can also do forecasting and financial prognosis. And if you have a powerful data factory, instead of giving the reports at the end of the month and a few days after the end of the month for various reasons, you can actually give the updated reports on a daily basis, so that how your how your financials are flowing and so forth. And this was very easy for us. We thought it would be difficult when we got the demand, but these things turned out to be really easy because the factory was in place. And this has much more business impact than any AI or machine learning, at least at the maturity level what we are today.
So you think this is going straight down to real hardcore operational waste on a daily basis in 90% of our Swedish businesses?
Exactly. And this, getting the data democratized so that people can use it, getting it structuring and building the factories so that you can do things, that gives that's where the bulk of the value in data processing is. It enables AI and machine learning and so forth, but you have to get grip on these things before you actually
but to conclude, if you get really good at the data factory idea, this is I talk about to become data and AI ready. So getting the data part right, the data processing part right, it's immediate value now, and it sets you up for AI.
Yes, exactly. It's a prerequisite.
It's a prerequisite, but it's actually you can squeeze value now.
Yes.
Even with the AI train also moving in its pace.
Yes. And maybe you've seen there's this triangle with the what's called, help me here, Anders, the Monica Rogati's
the Venn diagram, or what?
No, the fundamental needs of AI. What's called the basic needs of AI or something like that. It's a reference to a psychological model where you say that for you as humans to thrive, first we must have food to eat and shelter and the basic things.
For AI to thrive, it needs
exactly. And after you have food and after you have longevity and can protect your children and so forth, then you can realize yourself and paint art on the caves and so forth. Right?
Almost sounds like Maslow. So what's the Maslow of AI? Yeah,
exactly.
So the time is flying away here, and I hope that we can cover a few more topics in a very perhaps quick way, so at least have some of your ideas as well covered. And I know one of the things that I like as well that you mentioned is the hidden technical depth and the paper that Google wrote in 2015 or 15, right?
Yeah, something along that time frame. Yeah, it's a great paper.
It is, actually.
I was about to segue into that, actually.
Okay.
Because that illustrates if you do like machine learning applications, it illustrates how little effort that's actually spent on the core machine learning data science things, and how much effort is spent on the systems around to manage the data, to clean the data, to do the work with the infrastructure, to do the experiments and the logging and so forth, right?
It's a famous picture, I think, in that paper. I think it's like a small like
that's the
square.
one you've been sharing that picture a couple of times, I think.
And there are so many redrawings of that picture. I've redrawn it myself because of copyright reasons. Right? Yeah. And in every redrawing that I see, the little thing in the middle, it's much bigger on the redrawings because it's usually done by people that work with that little part, and they want it to be bigger.
So in short, there is a lot of like plumbing code, supporting systems that you need to have in place to actually use AI and machine learning in production, and people rarely underestimate that, or how would you describe it?
Absolutely, and they start off in the wrong order, right? They start with that little box in the middle. They hire a data science team, right? And then what happens? And that's if you're much better success if you do it in the other order, because you can. Most data-driven products look like that, but they're missing the little machine learning box in the middle, and those are really valuable products. Internal features for A/B testing or for web analytics or whatever, right? So you're much better off if you start building up the other boxes and building up your capabilities, and you can succeed with machine learning products at first. With perhaps little effort and little spikes, where you just focus on the middle thing. But once you get to a certain quality level, right? For example, if you do fraud detection, you can get to 70, 80 or something. But if you want to go beyond that, you need the ability to experiment and tweak a bit and measure and forward test whether things are actually working. And then you need a whole infrastructure around.
There's this concept called a prototype graveyard that I think we mentioned before a bit.
Yeah, I was just you picked it up now, so continue on this one. I had it on my tongue.
And a lot of companies that are not tech giants, they want to use AI, and they say they use AI, and they say they have AI in production, but in reality, very few actually has. But they do try, and I think a lot of companies try to build prototypes, saying, I'm using AI or machine learning for this and that. But very often it doesn't leave the stage of being a prototype to becoming something in production. And for one, would you agree with that?
Absolutely. I think Gartner concluded that 80% of all machine learning prototypes end up never going to production.
It has to have something with this map to do, that we think we do AI because we do the little small box in the middle, but we haven't really figured out the life cycle or the landscape around it to put it in production.
Yeah, and we can sort of sneer about it, but it's also a way of employer branding, right? It's a way to say that this is where we want to go, and we're showing it off with a demo. So it has some tangible value, but not necessarily direct business value.
So if you were to advise a company that want really to start becoming more data and AI driven and not ending up in the prototype graveyard, what should they try to do?
So, as I said, getting a grip on working with data is a prerequisite for getting machine learning and AI out there, at least in a sustainable manner. I've sort of discovered that after talking with companies that are less data mature and to do my best to help them along the path, that a prerequisite for becoming data mature is to become, in a sense, become agile, right? And being able to come up with an idea, test it out, figure out whether it worked or not, and based on that, learning, come up with another idea and do that cycle fast, right? A colleague of mine calls it build, measure, learn loop, and being able to do that, whether it has anything to do with data or not, right? Maybe it's very simple measurements. The ability to do that fast is a usually a prerequisite to going into to data factories and so forth.
So you're talking even here about the cultural mindset.
Yes.
That ultimately, if we are not even in the cultural mindset of elaborating, we have a waterfall culture, or we have sort of, then it's really, really hard to even get started.
And if you work in time cycles of like years or quarters, and so I think the most successful companies nowadays, they have figured out how to get these cycles really fast, and that has, for example, made the OKRs and somewhat outdated way to coordinate, because that assumes cycles of quarters. And that's I believe that's one of the reasons why Spotify left that and moved to these DIB things, because of if you.
So the DIB is the constant prioritized transparent list versus an OKR.
Exactly. It's going from the quarterly sort of sprints of OKRs to a continuously flowing, continuously changing.
What does DIB stand for?
Data, insight, belief, bet. So these lists were like bets, things that we said that this is the thing we should do.
And I believe also Spotify said, or I think it was Daniel Ek that said at one point, that Spotify, and sorry for paraphrasing now, and please correct me if I'm wrong, but I think he said Spotify is going to be the company that fails the fastest.
Absolutely. And that mindset, together with the enablement of enabling people to use data and democratization, has created some fantastic things. One of my proudest moments was when I watched the presentation of how they made Discover Weekly, because this was like this now 18 months after we did this data transformation and sort of democratized data within the company. And they said, oh, yes, we did this and this and this. And we did this in a hack week, right? It took a week to get the basic things in place. And we could do it so quickly because all of the things were already in place. We could use these data sets from that recommendation, and we could use these data sets, and we had these pipelines that were building playlists, so we could hook onto these pipelines and create a playlist and export it into the playlist service. And all of this was, none of this came from the top, right? None of this was a strategic decision that we're going to make this product in 6 months. It was all created by enable bottom-up innovation and enable innovation throughout the company. And I was like, wait, that's the enablement that we did 18 months before. And Daniel Ek was interviewed at some point, and he said, yeah, I heard about it. It seemed like a bad idea. So if I had been in charge, I would have, shut it down. But that's not how Spotify works. So when they asked for more people we just said no. And then the month passed, and they launched it anyway. And, a year later, they had 40 million users. So apparently I was wrong, right?
Super cool story.
So,
but this is about enablement and I think this is super cool also because the paradigm what Spotify is doing, what Epidemic Sound is doing, is I think it's the fundamental understanding of that on a lower level. There's a lot of in situation mode data products. So we are containerizing, we are making them more modularized. We're having a mesh of data products, and then we hook this up and we get this Lego thinking going. And I think this is very, very different ultimately to the monolithic approach or the data warehouse approach, or which I think is sometimes is very hard to grasp if you haven't lived it. Yeah.
And coming back to how do you become data mature, many of the companies that I meet them and I say, well, sort of Scling speciality is to execute things in production and
to truly get value. So
to iterate fast. From the moment that you say we have this idea, okay, can we set up a data flow? Yes, then we can get it out into production very quickly and iterate there. But the challenge with many of the companies that I meet that they are not ripe for. I meet them too early in the phase, so they are not ripe to throw things out into their ideas into production. They are struggling with enabling bottom-up innovation. I meet C-level, and they think that if they sit a couple of C people in the room, they can come up with great things. No, it's down there that the great ideas are.
Innovation hub. happen in the bottom.
Exactly.
So,
and getting
we have a few minutes left, and we have spoken about companies and how we can make that. But if we lift the view a bit and try to think about society, Sweden, Europe a bit, and we can also think about bottom up, as we said before, and top down approaches to just accelerate AI and AI usage. So if we were to have that thinking just generalized a bit more, and let's say that we want to become less dependent on tech giants, cloud providers, what would you advise, like Swedish or European politicians, to say this is actually how we could start to have a Swedish European data infrastructure that starts to catch up, perhaps not come to the same level, but at least start to catch up?
Mm-hmm. I think I would urge them to emphasize, to accept that innovation in this area happens in small or in a small clique of highly technical companies, right? If we look at the companies that understand data, AI, cloud scale infrastructure and so forth, there are very few of them, and there's no flow of that competence from the tech stars to outside. They just flow between each other and to the startups. Mm-hmm. So I think accepting that that's where the innovation will happen. Yeah, mm-hmm. Not with the old giants, not in academia, but in that clique of
so let companies. Me give 4 examples, and let me and you can choose what you think is the best approach. There are these things called like Gaia X and others that are basically like a top-down European approach to build a European infrastructure in different ways, and they try to coordinate that top-down in some way. There are other approaches. You can choose to invest in academia to have better education in these type of examples. You can choose to invest more in the bigger size SMEs or enterprise companies to say you really need to start the transformation into becoming a more data-driven and AI-driven company. Or you can choose to also invest in like startups and having a scene where startups can get funding and get started easily in some way. What do you think have the biggest potential? It's a hard question, I know, but...
Yeah, I mean, in a way, the natural answer is startups, but I don't believe that answer either, because there is a great company in Boston who also are sort of focused on these data ops and data factories. They're ahead of Scling in the journey. They're called Data Kitchen, and the CEO Chris Berg is a very eloquent data ops prophet, and this company is a bootstrap company. They never took capital, if I understand correctly. And he says that if you take capital and you sell a story, right, and you sell that story is going to grow. If you don't take capital, you bootstrap, then you need to sell value.
To begin with, so to speak.
Yes. And there is a difference. There's a significant difference between story and value. And few stories transform into value, but your focus for the first rounds of funding has to be the story. And I don't think that we need more stories. I think there are way too many stories about different ways that AI or blockchain or quantum computing, whatever it is going to be fantastic. I think we
touched so many interesting topics.
Can we go for an hour? Because we touched now. Robert Luciani was into this as well. Like, do you go for is your business model for venture cap or is your business model for value hardcore? Yeah. And then we talk about, oh my God, there's so many, we just got started.
Yeah. So I think that we need
And Data Kitchen and the whole grandfather of data ops that I wanted to talk to you about. And we need, we nestled in the data ops story throughout the whole conversation, but we didn't have a proper data ops conversation yet. Can we go a little bit more?
That's a good point.
If we try to wrap it up, and let me see if I understand you correctly, Lars, and it's in some way...
I don't want to wrap it up.
In some way, it's about moving to value quickly. Would you agree with that? Both in terms of startups not having stories but having values. Also for companies that want to start to use data, they have to quickly turn it into some kind of value. And then you need Scling and other companies to help them bootstrap at that journey, right? Or how would you summarize?
Yes, but that doesn't necessarily solve the cloud and infrastructure, the lack of a European cloud vendor problem, right? Yeah. Because then you also have to sell a story in a way that this is going to fly.
So more long-term problems are not solved by.
I'm running a bootstrap startup because I believe so much in generating value, and I think that can fly. And I don't want the life of a story selling startup. That's not how I work.
But I need to inject what we talked about with Robert Luciani, because we were joking about it, how to spend money on startups. And the venture cap story we all understand, and we don't want to sell your company away. But we had exactly that story. How do we support and invest heavily in the startups without expecting them to give away their value? So we joked about it, but I'm dead serious. How can we do arbetsförmedlingen for startups? Like if we are throwing out money to support people to get a job and it's for free, how can we create an infrastructure to support the bootstrapping type strategies without injecting them with money and expect the story?
I think you're onto something here. So this reminds me of I was at what's it called, Svenska Handelskammaren, the trade
trade council.
Trade council, yeah.
Something like this.
And at some point, and I asked them, so if I, as a small startup, if I am sued by a patent troll, like can I get help? No. We have no help for you, right? And this is a kind of insurance that actually the state or the government or EU or some
we can help the bootstrapping strategy.
Yeah, and provide us with a safety net to all of the weird things that can go wrong, like IT security and economic weird things and patent trolls and so forth. And that would be a very reasonable way to sort of boost startups. That's much more valuable.
Much more valuable than the venture cap approach or throwing money into stories.
Yes,
I fully agree on this.
And also you could do various things with open source. For example, demanding that academia funding goes to open source things and so forth. I'm not sure what the right model here is, but I think that trying out new approaches like that would lead us further than just throwing money things.
Awesome. I wish we had more time, but let's try to close it up a bit. And if we start by asking a bit, what's next in your life, Lars?
Next is definitely to iterate on sort of the Scling model, and until we have figured out how to make that work in a sustainable manner, and get the look at the first few clients and see what is the model that actually make it work, and get that up to a sustainable level.
Sounds good.
Yes,
and perhaps make it work for not only companies but Sweden and Europe.
Absolutely, well. And what drives me here is not success as an entrepreneur, but I want to give these powers to all of the good companies that are out there. If you look at Scandinavian companies like H&M, IKEA, Volvo, and so forth, they really align with my values in very.
They just lack your knowledge in data.
Yeah, but and this goes back to the data AI divide we've talked about. That sort of, the best way to get a good, inclusive, diversified society is to make sure everybody's in on the ride. So we are getting a new type of poverty, we will have a new type of society if we're not careful now, driven by the AI divide. So I think how to disrupt from within companies or support these companies rather than they being disrupted from a tech giant, that would be much, much healthier for our whole economic system.
Exactly. And that's my mission.
Mine too. That's my mission too.
Mission.
That sounds awesome. Lars, is there anyone that you would recommend to be on this show that you think could be interesting for you to listen on?
Oh, that's a good question. I haven't prepared an answer for that one. Sorry, I'll have to get back to you on that one.
No, not that easy. Not that easy. Come on.
Getting off the hook here.
You're not getting off the hook. Sorry.
So this
pull something out of your whatever.
In that case, I would say Fredrik Olsson, researcher at RISE.
Yes,
he's one of the top natural language processing researchers in Sweden.
Oh, yeah.
Cool. And amazing character. Ask him about his relation to Jonas Gardell.
To who?
Jonas Gardell.
Oh, really?
Yeah,
that would be
that's a cliffhanger.
Yeah, now we have to get
that's a cliffhanger.
Exactly. Yeah. Just a little anecdote.
Awesome. So nice to see you again, Lars. It's been far too long since the last time.
One last question. I heard about this music rivalry at Spotify, dance bands versus Iron Maiden, or is that true?
Not Iron Maiden, but yes, that goes back to to the time when Anders and I was sitting more or less next to each other.
Yeah. Were you cranking up the volumes?
On Fridays there was this tradition to have casual Friday, which means that we had this shared playlist going on all the time, and that was usually bearable mainstream stuff. But every once in a while, Anders would put some dance band stuff, Lasse Stefans or whatever it was.
And what would you counter with?
I cannot work to that kind of music, right? So I had to counter with something that prevents others from working. So that would typically be like some industrial electronic, like frontline assembly or front 242 or something.
What a great
and then we had a terror balance.
Fun times. Cool.
Awesome to have you here, Lars. Thank you again, and I wish you a happy evening and a continued career.
It was a pleasure.
Thank you very much.